Here's all our components laid out and labelled to start the project. So we have the original PCB with the 6 panelised versions, and then broken off so you can see the top and the bottom and all the capacitors, resistors, etc. that make up the project. So now we start putting it together. I always try and start with the SMD first, so I'm just putting a dab of solder on one side and then lining up each piece and put a dab of solder on the other side. So I've started with the lights and the resistors, current limiting resistors for those lights. Now I'm grabbing the different capacitors, the C1, C2 and C3 capacitors. Now we have R1, the fixed version, and R2, the fixed version. And then that's the 10 NF capacitor between pin 5 and ground, and then over the other side of the PCB that's the decoupling capacitor, which is 100 nanofarad. So I'm just trying to fix on the 555 timer. I put one pin on and then soldering up the other pins. Now the double header, which is used as the selector for the capacitors, and one of the pins came out, so I've solder suckered that out and started again. That's fine. Put the selector on. This is the 500 kilo ohm potentiometer. And now we're looking at the headers for ground, VCC and signal, and the headers for VCC and ground on the other side of the PCB. Which was giving me a bit of trouble, so let's suck it out and start it again. And that's got it. The last thing are the spaces, M2 spaces on each corner, so the PCB stands. And then power. And we'll switch to normal speed so we can have a look at the actual 555 timer generating the signal. That's the 1 microfarad capacitor, and now winding that to increase R2, which increases the frequency. And back. Now we swap the selector. And you can just see those frequencies. But when I move it to the last one, which is the smallest capacitance, it just looks like a steady line. So now we're up into the kilohertz, so the eye's not going to pick that up. But that's the circuit working.